Hey everybody, Mr. Quick here. Today we're going to look at Eureka Math / Engage New York Math, Module 3, Lesson 16, Symmetry in the Coordinate Plane. You may remember symmetry from art class, and I know my picture's not going to be very good, but if you think about a face, if you think about the perfect shaped face, which that's certainly not, if you created a line of symmetry, that means you can go right down the middle, and you could fold this picture in two, this going this way, this going this way, and the eyes would match, the nose would fold over on itself, and the smile would fold over on itself. Same thing if you think about a square. That's not the best square, but I'm drawing freehand here. If you took a square, you could fold it this way, and both sides would fold completely over perfectly. You could fold it this way, and they would fold over perfectly, right? There's other lines of symmetry as well. In the coordinate plane, which is this bad boy here, remember we have quadrant 1, 2, 3, and 4. In the coordinate plane, we're going to talk about, there we go. We're going to talk about what symmetry means in the coordinate plane. And one of the first things we need to talk about is the concept of opposites. When it comes to numbers, when two numbers are only different because of the sign that they have, positive or negative, then they're considered opposites of each other. -2, the opposite of -2 would be +2, right? I don't have to write the positive sign, but you see that they have different signs, so there you go. -3, its opposite would be 3. 17, its opposite would be -17, and so on and so forth. We're going to continue that by talking about opposites on the coordinate plane and talking about reflections. Now, you know, if this was a mirror and you were to look in the mirror, that's me, I guess, you would see a reflection, right? That's not perfect, but hey, good enough. You see a reflection, so you see the same thing on the other side of the mirror. When we look at the coordinate plane, we can also see reflections, and usually that's related to opposites. So, we're going to do a little example here. I'll give you an ordered pair. 3, -4. You remember that the first coordinate is the y, which is this. Second coordinate is the, I'm sorry, I said that wrong. The first coordinate is the x, which is that. I just said the wrong thing. The x-axis. And second coordinate is the y, which is this, right? So if we have 3, -4, we're going to go over 3, 1, 2, 3, and then once we're on 3, we're going to go down 4, and we're going to mark where the 3 and -4 meet. We know that's in quadrant 4, and there you go. If I give you a second ordered pair, which is -3, -4, what have I changed? Hopefully you're noticing that the only thing I changed, the -4 for the second coordinate, the y-axis, the y-coordinate, is still -4. It's the same. But I've now, instead of 3, I'm using -3, so I'm using the opposite of 3. So in this case, we'd start at our origin, which is 0, 0, and we go back 3 to -3 here, and then down 4. So we went back 3, down 4, and we're going to mark that right about there. Now my markings are not perfect. It's hard to do it on the iPad screen. But what I'm hoping that you notice is that these are the same distance apart from 0, right? So -3, 4, we have 1, 2, 3 to get to 0. +3 would be 1, 2, 3 to get to 0. They're just on opposite sides of the y-axis. Basically putting these as opposites, putting these as a reflection. So think about the y-axis as a mirror. This is a reflection over the y-axis because it's in the same position, but it's just on the opposite side. I know that may be a little new, a little confusing. We're going to look at a few examples here together. All right. We're going to almost do this like a map. We're going to follow it like a map. So we're going to begin at 4, -5. That's our ordered pair. Then we're going to reflect over the x-axis. That's step 2, step 1. And then move 7 units down, and then move right 2 units. It's almost like you're being given directions. Where would you end up? Well, let's take a look. So first of all, we have to start at 4, -5. So I'm starting at my origin right here in the middle, right? I'm going to go over 4, and since it's -5, I'm going to go down and end up right about here. Let's see if I can get that a little bit better. All right, there we go. My dog made a little guest appearance there. So we went over 4, we went down 5. So we went X, Y. Then it wants us to reflect over the x-axis. So if we remember that this is our x-axis, that's why it's labeled X, then if we went over 4 and down 5, to reflect, we have to go over 4 and up 5. So we'd end up about right here. So those two points are reflections of one another because they're on the opposite quadrant. They're on opposite sides of the x-axis. So now we started here. We reflected over the x-axis. Now it wants us to move 7 units down. Well, if it's at over 4 up 5, we're going to go down 5 and then down another 2. So we're at 4, -2. Mark that right there. And now it wants us to move to the right 2 units. So we're here, we're going to go over, and we're going to end up right there. And hopefully you see that now we're over 6 and down 2. So we went over 6 and then down 2. So where did we end up? We ended up at the coordinate which is located at 6, -2. All right. So as we moved, it is almost like directions. It's like almost being told how to move throughout the city, right? But one of the key things is knowing that your opposite or your reflection, it doesn't really matter. Move this out of the way. It doesn't really matter which axis it asks you to reflect over. You just have to know which one is which. So if I'm at, let's say 9, we'll go 9, 3. Right there. I was always wanting to move my stuff around. 9, 3. If it asks you to reflect that over the y-axis, then you would go up 9, back 3. So you would go to -3. Sorry, it's been a little tricky here. There you go. If you were asked to reflect over the x-axis, again, you're going to go over 3, but this time you're going to go down 9. So again, over 3, up 9, or over 3, down 9. So it just depends which one they want you to reflect on. So just remember, it goes x, comma, y. X is always either going to the right or the left. Y is always either going up or down, depending on whether the number is negative or positive. Now, one exercise you may see today would be for you to describe how to navigate, move around the coordinate plane. So if I said, all right, I want you to start at 9, -3. That's going to be our starting point. And I want you to end, that's a goofy looking end there. I want you to end at -4, -3. How would you do it? Use only one reflection. So you only get to reflect once. So we're going to start at 9, -3. So we'd go over, we'd start at our origin, right? Go over 9, down 3. And if we reflect, we'd have to reflect, I'll just put R for that for the sake of it, over the y-axis. So we would end up at -9, -3. That's just with one reflection. We want to end at -4, -3. So to get there, I'm going to go ahead and mark it just so I can see. To get there, we'd have to go 1, 2, 3, 4, 5 spaces to the right. So your directions would be start at 9, -3, reflect over the y-axis, then move 5 spaces to the right, and you'll end up at -4, -3, which is just where they want us to end up. We're going to do some more examples of these together in class. It's hard to do this on a video, but I did want you to have this as a reference and be able to look back on it and kind of use some of the terms, see some of the terms that we're going to use in class. So we'll talk more about this when I see you. Thanks for watching, and we'll see you soon.